All right. That's an interesting question. You're asking him and not me?
You were busy. He wasn't.
I'm the boss. He's my assistant.
Well, that means you should know the answers.
Not necessarily. You know how this UNC Charlotte works. No. No. All right. So yes, we have class on Wednesday. My goal is to get you guys back your test and to also help you out with reviewing for the final exam. So I'll do another review for the final exam on that day too. All right. So here's the thing. Just to remind you guys, you got a big homework set due when? Friday. And I made this a big homework set because if you know this stuff inside out, you will ace my test. Because you know, even though I haven't made it up yet, the test is going to look just like the homework set. Probably will be the homework set. You never know. So study this thing very well and make sure you guys can do this stuff. So now if you have a particular question or one or two questions on the homework set, I'll help you guys go over that, especially if it's on the wording stuff. I'm not going to do a bunch of questions on the homework set because that's what Friday's all about. But I also plan today I'm going to take an old final exam and show you the format of the final exam, because I want you guys to also get into final exam mode, because we got a week before final exams, a week and a half basically, before you guys have to endure this final exam stuff. So I want you to show you the format on that. So just to remind you that homework number 3 is due on Friday. You have your test on Monday. Also, please go in and do the course evaluations, especially since this is a pilot course in terms of the Hawk system and the videos. Also make comments if you like me doing the videos in the class and you think that's been advantageous and helpful. Please also make comments on that, because you know the university is always looking for places to do budget cuts, and videotaping classes on the computers and stuff is one of those things that can be put on the chopping block at any time, unless we can show that the students really need this stuff and really utilize this material and stuff. So please do make comments on that and any other aspects of the course and stuff, because, you know, like I said, it being a pilot course, they're going to be very interested. They, being the administration, will be very interested on your comments on the Hawk system, if you liked it, didn't like it, good things, bad things, the whole 9 yards, as well as the notes and how we did the notes in class. Most professors aren't doing notes and stuff. They just go in there and start doing an example on the board and just, you know, the traditional way. We're trying to help you guys out with kind of getting preset notes and stuff like that. So we got kind of the questions already, and all we got to do is do the answers and stuff. So work it together, give you guys a chance to actually learn how to take math notes and stuff. So please do make comments on that. And the last thing is this. Just to remind you, I keep drumming it into you guys just to make sure you guys understand. Thursday, December 10th, which is next Thursday, we have the big review session where I'm going to be going over in its entirety last semester's final exam. Okay, it will be, the review session will be in here for Fretwell 100, and it will be from 2:30 until 5. And again, I'm going to go through strategies on how to do a standard common final exam and some of the tricks of the trade and what we're actually looking for. And I'll talk more about that actually when I do some of those things today as well. But that also means that the final exam will be the following day, because it's a common exam. Common exams are all on the same day. It's that first Friday when exams start, December the 11th. Our exam is going to be in Fretwell 121, and I'm afraid the exam starts at 8 o'clock in the morning, which means you got to be sitting in your seat and filling out forms and all this other stuff at about 7:30 in the morning. So, and again, it's a 3-hour exam, so you got 3 hours to take your time and do this thing. Most folks, honestly, finish the exam within about 2 hours. But you have 3 hours in case you're one of the students that want to go back over questions, or you're a little bit slower on getting the details on a question. You've got time on this thing, but it is a timed exam. At 3 hours, you have to put your pencil down and have to shut your test booklet and stuff. So, all right. So, as I said before, I brought a copy of the homework number 3 here. And is there any particular question that you guys, besides the whole thing, yeah, I know that, but is there any particular question that gave you guys some difficulty that I could help you out with on this thing? Yes, ma'am. Number 6. Like I said, to answer everything is not an option here. A particular question, I will do, but I'm not gonna do the whole thing for you guys. I want to do one or so because, I try to give lots of similar examples and stuff. So once you get one, you should be able to do the other ones just like it. This is problem number 6. Problem number 6 is asking you this. Solve the equation x cubed minus 6x squared plus 7x plus 2 equals 0. Given that one of the solutions is 2, you know one of the solutions is 2. Now remember, this is a polynomial equal to 0. When you have a polynomial or any function equal to 0, you're looking for the solutions called x-intercepts, roots, or zeros. And they're telling you one of my zeros is negative, as x equals 2. And you notice in your solution set, 2 is an option on every one of them. The question is, what's the other solutions? But if you've got a root, a 0, an x-intercept, you can actually reduce this polynomial by doing synthetic division. So I can take that root, which is 2, and divide it into the coefficients, using synthetic division, of the polynomial, which is x cubed minus 6x squared plus 7x plus 2. But remember, synthetic division uses the coefficients of each term. That would be 1, negative 6, 7, and 2. There is no term missing. There's x cubed, there's x squared, there's x, and there's constant. You skip a line, draw a line, synthetic division. You bring down the first number, 1, then you multiply. 2 times 1 is 2. Above the line you add. Negative 6 plus 2 is negative 4. Below the line you multiply. 2 times negative 4 is negative 8. Above the line you add. 7 minus 8 is negative 1. Below the line you multiply. 2 times negative 1 is negative 2. And then you add and you get 0. And remember, the last term is the remainder. And being that 2 is a solution or a root or x-intercept, I was expecting the remainder to be equal to 0 because we know this thing factored. Does that make sense? But when you do this, this is your root, 2. Your factor is x minus c. So the factor on this thing would be x minus 2. The rest of the polynomial is actually located down here. And how to figure out what that polynomial is, you build it up from the back. This is the constant term, this is the coefficient of the x term, this is the coefficient of the x squared term. So pretty much this polynomial, x cubed minus 6x squared plus 7x plus 2 equals 0, this polynomial turns into the factor x minus 2 times this polynomial, which is 1x squared minus 4x minus 1. So we factored the polynomial. But the root 2 came from the factor x minus 2. Where are the other 2 roots going to come from? The quadratic factor. So to figure out this solution, you take the x squared minus 4x minus 1, set it equal to 0, and solve. The problem is this is a quadratic. The other problem is this thing doesn't factor. What do you do when you have a quadratic that doesn't factor? Quadratic formula. Sing along if you know it. X is equal to, what is it? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, we expect you guys to have this thing memorized. All right, now, in this particular problem, a is equal to the coefficient of x squared, which is 1. B is equal to negative 4, the coefficient of x, and c is my constant term, negative 1. So when I plug it in, I get negative b, which is negative 4, plus or minus the square root of negative 4, quantity squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. So I get x is equal to negative 4, plus or minus the square root of negative 4 quantity squared is 16. Minus 4 times 1 times negative 1. Negative 1 times 1 is negative 1 times a negative 4 makes it a plus 4 all over 2 times 1, which is 2. 4 plus 16 is 20. This is 4 plus or minus the square root of 20 over 2. But I can clean up the square root of 20 because I'm always trying to come up with these problems that kind of review you on old Final exam material, how do you clean up the square root of 20? What times what is 20 that I could actually take the square root of? 4 times 5, 4. So 20 is 4 times 5. So 4 plus or minus the square root of 4 times 5 over 2. But the square root of 4 is 2. So this is 4 plus or minus 2 square roots of 5 over 2. But to clean a quadratic up, when you have a single denominator, you want to put that single denominator under each term in the numerator. This will be 4 over 2 plus or minus 2 square roots of 5 over 2. And when you clean it up, 2 goes into 4 2 times, that'll be 2, plus or minus, here the 2's cancel, you're left with the square root of 5. So again, what were the solutions, which is known as my zeros on this thing? Roots, zeros, all the same thing. The first one was 2 because they gave me that. The other 2 are right here. It is 2 plus the square root of 5 and 2 minus the square root of 5. The plus minus from the quadratic formula. So which one of these guys is my answer? The answer is B. But I want to remind you guys, when you guys turn this homework set in, no work means no credit. I just told you what the answer is. The answer is B. If you got no work at all and you circle B, how many points you going to get for that? I'm actually probably about an extra minus 20 just for making me look at that thing. So show your work on this. Yes, ma'am.
Can you go over the last part again when you were trying to get rid of the 2?
Oh, okay. So I have a single denominator here. Through my quadratic formula, I got 4 plus or minus the square root of 20 over 2. I cleaned up the square root of 20 because 20 is 4 times 5. And the square root of 4, with strict multiplication division, I can break up a radical. The square root of 4 is 2, so I wrote it as 4 times 5. And the square root of 4 is 2. So this is 4 plus or minus 2 square roots of 5 divided by 2. But this is plus or minus. When you have a single denominator with terms in your numerator, you take that denominator and put it under each term in your numerator to kind of break up your numerator. So this is 4 divided by 2 plus or minus 2 square roots of 5 divided by 2. And now you've got individual fractions, you can cancel and clean that stuff up. 4 divided by 2 is 2. And 2 square roots of 5 divided by 2, the 2's cancel, just leave me with the square root of 5. That's how I got it.
Okay.
Sure. Yes, ma'am.
I had some questions from the homework. I'm not sure if there's problems like it. Might as well ask it.
Which one? Sure, go ahead. What you got?
Well, for 8.1,
Yeah.
how would you, if it was a dependent solution, then how would you write the answer?
Okay. Tell you what, I'll help you out with that, doing it 2 ways. I want you guys to turn to the last page on this homework set. This problem right here. You are not, okay, so I'm gonna do 2 different problems. I'll do this one and I'll do another one that's not on the homework set, so I can help you guys out. But it's this problem right here. All right. I want to solve a system of equations here. I got 2 choices. And on this one, I didn't care what method you use. You can use the elimination method or the substitution method. On this one, I want to substitute because I set it up for substitution. Look, I wrote y equals 3x plus 35, and then the other equation is 4x plus 2y equals negative 20. This is prime for substitution because the variables don't line up. Just replace this y down here with 3x plus 35, clean it up and go solve for x, then you have to back substitute to solve for y, and you'll get a unique solution. This one is more of an elimination method because my x's line up, my y's line up, the equals line up, and my constants line up. So I can multiply the top equation by some number and then be able to add it to the bottom equation to eliminate one of the variables, the elimination method. On this one, I don't care which method you use because something special is going to happen to you. Personally, because my variables line up, the x's line up, plus the y's line up, equals the constants line up, I would use the elimination method. If I was going to eliminate, doesn't matter, which variable would you like to eliminate? The x's or the y's? Your choice. You want to eliminate the y's or the x's? All right, the y's. Fine. Okay? How do I eliminate the y's? I gotta have the same but opposite coefficient. The same number, but a different sign. This one already has a negative, this one has a positive. This one's a 2y, this one's a 6y. What do I need to multiply by a 2y to get a 6y? 3. So I'm gonna take that top equation and multiply the whole thing by 3. What I do to one side, I do the other. What I do to one term, I do to all terms. And this 3 is gonna distribute all the way throughout. 3 times 4x is 12x. 3 times minus 2y is a minus 6y equals 3 times 9 is 27. Okay? The other equation, just copy it down below it, is negative 12y plus 6y equals negative 18. The purpose of elimination is make sure that one of your variables has equal but opposite signs. So I'm going to add these equations together to eliminate one of the variables to create a third equation that has one variable in it that I can solve for. But when I do this, what do I get? What is 12y minus 12? I screwed that up. What is 12x minus 12x? 0. It happens to cancel. What is negative 6y plus 6y? 0 equals, what is 27 minus 18? 9. This is one of these dependent sets. Okay? Here's the problem. Is it consistent or is it inconsistent? Let me put it in English. Is the answer no solution or all real numbers? You can tell by what's left of the resultant. You got an equation, a statement. 0 equals 9. It's either true or false. If the statement that's left over is true, the answer is all real numbers. There's an infinite number of solutions. If the answer is false, then the answer is no solutions. And we write the word no solutions or the famous D and E for does not exist. So here's my question. Does 0 equal 9? No. Since this is a false statement, 0 does not equal 9. The answer is no solution. Because all your variables cancel and I got a false statement. So the answer is no solution, or I would also accept does not exist. Does that make sense? Versus, let me finish up this one and I answer your question again. If I gave you this problem, let me make up a different problem down here at the bottom here. Or let me just do it on a different piece of paper. That would probably be best for most folks. All right, so here we go. Here's an equation. X minus 3y is equal to 6. And I got negative 2x plus 6y is equal to negative 12. I want you to solve the system of equations. Your call, elimination or substitution. At this point, we're just real excited that you guys got us an answer. So, any way you want to, get an answer. But honestly, because my variables line up like such, I personally would prefer doing the elimination method on this one. And I'm going to eliminate the x's. So how would I eliminate the x's? I want to make sure I get equal but opposite coefficients. So this one has a negative 2x, this one's a 1x. I would multiply the top equation by 2. When I do that, this is what I'm going to get. I'm going to get 2x minus, distributing the 2 all the way throughout, minus 6y equals 12. And the bottom equation, I got negative 2x plus 6y equals negative 12. When I add them together, what do I get? I get 2x minus 2x, that cancels. But also the negative 6y plus 6y cancels, equals, but most important, what do I get on the other side? 12 minus 12, which is 0. In this example, I got 0 equals 0. Everybody eliminated. So in your dependent problems, you're going to get all the variables eliminated. Does that make sense? But the question is the answer going to be a 50-50 shot here? Is the answer no solution, or is it all real numbers that basically these are the exact same lines, so there's an infinite number of solutions? And because 0 does equal 0, this is a true statement, there's an infinite number of solutions. So the answer is all real numbers. Does that make sense? Because basically we just discovered that these two equations are the exact same equation. These are your, and I threw one of these guys on your test, on your homework set, but The fact is, most of the problems when you're doing with the systems of equations, you're looking for that single one-point intersection. You solve and you get x equals 5, you plug it back in, you get y equals 27, and you get 5 comma 27, and that's the way you write your answer. Does that make sense? Okay. Other questions? Did this make sense? Okay. Other questions on the homework set here? Yes, ma'am. 13. Okay, that seems to be a popular statement here. All right, fine. 13. So here we go. Let me find number 13. All right. I'm going to let you know right now, 13 and 14 and problems of this type, you can anticipate seeing on my test because I know they're going to be put on the final exam. There's a question like this on the final exam. So make sure you know how to do this one. All right, this one is honestly the toughest. Anytime you're solving a quadratic or polynomial or rational function inequality, the first thing you want to do is pull everything to one side and compare it to 0. Because with these type of problems, you're looking for we're going to do the number line bit where we're looking for where the answers are positive versus negative. Positive means you're above 0, negative means you're below 0. So the first thing you've got to do is set the inequality to 0. So the first move I'm going to make is I'm going to subtract 1 from both sides. What is 2 minus 1? 1 plus x over x minus 1 would be less than or equal to 1 minus 1 is 0. You've got to set the equation to 0. The next thing you're going to do on this one is, because this was a rational function, you want to create a common denominator and combine like terms here. You want to basically add 1 plus x over x minus 1. But, 1 is a fraction. Let me show you. It's now 1 divided by 1. But to be able to add or subtract fractions, I got to have a common denominator. What is my common only denominator in this problem? X minus 1. So this one is x over x minus 1 plus, but the 1, whatever I do to the bottom, I got to do to the top. So I'm going to get the common denominator. I'm going to multiply the bottom by x minus 1, which means I got to multiply the top by x minus 1. And it's still less than or equal to 0. I'm trying to create a common denominator, which is what I got. So when I write it, when you have a fraction plus a fraction and you have a common denominator, you write it as one big common denominator, x minus 1 in the bottom. And in the numerator, you've got, everything goes in the numerator. You've got x minus 1 plus x is less than or equal to 0. Well, might as well combine like terms. What is x plus x? 2x, combining like terms. So I clean this up. This is 2x minus 1 over x minus 1 is less than or equal to 0. Now, all this work is just to get the equation in the right format. I either want polynomials that are factored, or I want to have rational functions, fractions, numerators, denominators, one big fraction. Does that make sense? Now, here's the deal. Two things. Because this is a rational function, this guy has a vertical asymptote. Where's the vertical asymptote at? The vertical asymptote is the point where the function does not exist. And when does a function not exist? When you divide by 0. So to get the vertical asymptote, you set the denominator x minus 1 equal to 0. Solving for x, I get x equals 1. But you see, x equals 1 is a vertical asymptote. That is a point that my function does not exist at. So on my number line, I got to put a little open circle on that guy because I cannot have 1 in my answer set. Does that make sense? So the next thing I want to find is the vertical asymptote, which is x equals 1. I'm going to put that on my number line. The other one is I'm going to set it equal to 0. So I'm going to come over here and talk about the 0 of this equation. I'm going to take the equation 2x minus 1 over x minus 1, and I'm actually going to set it equal to 0 to figure out where the, quote, 0 is at. How do you solve when you have a fraction equal to 0? What's the next move you're going to make? Multiply both sides by the denominator. Multiply both sides by x minus 1. This will cancel on the left, leaving you with 2x minus 1 equals, what's 0 times anybody? 0. So when you're looking for a 0, it's just like saying the numerator equal to 0, because that's what happens every time. Now solve for x. I got 2x minus 1 equals 0. I would add 1 and then divide by 2. When I do that, what do I get for x? X is equal to what? 1/2. But here's my question. This is the 0 of the polynomial, or excuse me, the rational function here. This is the 0 of the rational equation. Do you want this 0 in your answer set? Yes or no? And how do you know yes? Because the original equation, after you cleaned it up, still has equal to in it. Because of that equal to 0, we want 0. So I'm going to put a little filled-in dot to remind me to use brackets when it comes to 1/2, so I can include that in my solution set. Does that make sense? Now, because it's an inequality, I want interval answers. When you have inequalities with these rational or polynomials, you want to draw a number line. And put these numbers on your number line. My 0 number is 1/2. My vertical asymptote is 1. So I have 1/2 and I have 1. 1 is a vertical asymptote. That's got to be an open circle because I can't include that point. But 1/2 is where the equation equals 0. So I want to include that point with the filled-in circle to remind me to include that. Now we're going to do test values. Because here's my equation that we're doing test values on. The equation is 2x minus 1 over x minus 1. I'm going to call this my function f of x. This is my function. And remember, I'm looking for when it's less than or equal to 0. Less than or equal to 0 is called negative numbers. The answers where the negatives occur at is where my solutions are. So I'm going to do something called test values. Pick any number. All you need is one number between negative infinity to 1/2. Use your brain. 0. Good choice. 0. So I'm going to plug into this equation 0. This would be 2 times 0 minus 1 over 0 minus 1. When I clean it up, 2 times 0 is 0, minus 1 is negative 1, over 0 minus 1 is negative 1. Negative 1 divided by negative 1 is positive 1. I don't care what the number is. What's the sign of it? If the answer is positive, so everything in this interval is positive. So pretty much, I don't want this answer in my answer set because I'm looking for less than or equal to 0. I'm looking for the negative guys. So come over here, and now pick a number between 1/2 and 1. And I'm afraid you got to go decimals on this one. What's a number between 1/2 and 1? 0.6. Good choice. 0.6. So f of 0.6, because 1/2 is 0.5. Something between 0.6 and 1 would be 0.6, 0.7, 0.8, 0.75. Any one of those numbers would have worked. Just a number inside this interval, 0.6. So this would be equal to 2 times 0.6 minus 1 over 0.6 minus 1. And because you chose 0.6, I'm going to definitely use a calculator on this thing. All right, parentheses around your numerator. 2 times 0.6 minus 1, close parentheses, divided by parentheses 0.6 minus 1. And let me slide it over, you guys can see it on the dark screen there. Does that make sense? Parentheses around the numerator, parentheses around the denominator. What do I get? I got negative 0.5. I don't care what the number is, it's negative 0.5, but what number is it? It's negative, so everybody in that interval is going to be negative. Now I got one more test value to check. Pick a number bigger than 1. 2. So I'm going to plug 2 into my function, and that would be 2 times x, which is 2 minus 1 over 2 minus 1. 2 times 2 is 4, minus 1 is 3. 2 minus 1 is 1. 3 divided by 1 is 3. 3 is a positive number, so everybody in that interval is going to be positive. Does that make sense? What kind of answers are we looking for? Because 2x minus 1 over x minus 1 is supposed to be less than or equal to 0, I'm looking for the negative answers. Where are the negative answers at? between 1/2 and 1. We want to include 1/2 because that's where it's equal to 0, but we cannot include 1 because that's a vertical asymptote. Does that make sense? So what would my answer set be? Bracket 1/2, because that means bracket means include 1/2, comma 1, parentheses, because we can't include. So parentheses excludes 1. So what is my answer? Answer's A. And again, this is guaranteed to be a kind of a question on your final exam. So study this one, because that's worth like 5 points right there. Does that make sense? Questions? All right, another one. Yes, ma'am. Number 2. All right, let me flip over here. Number 24. Yeah,
How many questions are gonna be on the following?
37. Yeah. I've seen the final exam. I don't know. They just like 37 this year. Not 40, not 20, not 35, 37. Okay. Which makes them a little bit more than 2 points apiece. Okay. All right. Take a look at number 24. You said, quote, you started it. Okay. Well, let's start it together. Look at this equation. I got the log of 5 plus x minus the log of x minus 5 equals log 3. First things first. What kind of log's on this thing? What base is on this log? Understood to be 10. When they don't write a base, this is called the common log or base 10. But the next thing you should notice is this. This is what I call a type 2 log equation. I got logs on both sides. How do you solve a logarithmic equation when the logs are on both sides? You combine logs on one side, you combine logs on the other, and then you cancel the logs because they have to be the same type of log on both sides. And then you use algebra to solve for x. But how do I combine logs? So this is a subtraction. What does subtraction turn back into when you want to combine logs? Division. Notice that the coefficient in front of the logs are 1. If there was a number in front of the log, you can't combine logs until you put that number back where it came from. Coefficients in front of logs go back as exponents. But only when you got coefficients of 1 in front of logs can you use the log property that multiplication turns into, addition turns back into multiplication, and subtraction turns into division. So if this being subtraction, this will turn into the division of log of x plus 5, the positive guy on top, divided by the negative guy, x minus 5 goes in the denominator. Equals, this has already been combined, log 3. So I've got the log of x, 5 plus x over x minus 5 is equal to the log of 3. I got log of garbage equals log of garbage. I'm trying to solve for x, I need to eliminate the logs. But because there's logs, the same logs on both sides, you can officially, what I do to one side, I do to the other, I can cancel logs. Now what mathematical procedure allows me to cancel logs is this. Remember, a raised to the log base a of x equals x. When you got a log, you raise it to the exponential of that. This is what base right here understood to be 10. So I'm over 10 raised to that log will be equal to 10 raised to that log, and officially you can cancel the logs. That means that 5 plus x over x minus 5 has to be equal to 3. The logs cancel. This is a log type 2 equation. Yes, ma'am.
Since it's like a given, those logs be canceled, do we have to show that one little step that?
No, it's understood, but I am trying to reinforce this with why it is, because you can raise it to 10. But basically, I cancel log on one side, I can cancel log on the other. Now, how would you solve for x now that you've cleaned it up and it turned into a fraction equals 3? What are you going to do next? Multiply by the denominator. Multiply both sides by x minus 5. This will cancel on this side, leaving you with 5 plus x is equal to 3 times x minus 5. What you going to do now? I'm going to multiply the 3 or distribute the 3. That's going to give you 5 plus x equals 3x minus 15. What you going to do now? Let's solve for x. Get all the x's on one side. I would subtract x from both sides. That gives you 5 equals 3x minus x is 2x minus 15. Personally, I would add 15 to both sides. This is going to be 5 plus 15 is 20, is equal to 2x. And then I'm going to divide by 2 on both sides to get my solution, x equals 10. But here's my last statement on this question. Are you done? You're never done with log equations because you have to, quote, check your answer. But you're not checking to make sure it's right. You're checking to make sure you're not going to violate the rule of math of you can't take the log of a negative number, nor can you take the log of 0. So just double check by taking 10 and plugging it back into the original equation. What's 5 plus 10? 15. That's nice and positive. I'm good to go. What is 10 minus 5? 5, but 5 is still positive. That's good to go. So this is actually a real solution. So the answer is 10. A lot of these multiple choice questions, they would put E does not exist. Because in case I came up with this problem and the answer was 2, I got x is 2. But when I go back and double check 2, 5 plus 2 is 7. That was good. But 2 minus 5 is negative 3. That would have been bad. Therefore, I couldn't have had that answer. And then the answer would have been no solution or does not exist or something like that. So you have to check your answers after you do all your math work. But 10 clearly does work. Does that make sense? Other questions? Yes, ma'am.
Can you do 3 on the free response?
3 on the free response. Okay. Three on the free response. This is one of those chapter 5 questions here. Given f of x equals 2x cubed minus 11x squared plus 7x minus 6, use the remainder theorem to find f of 2, and don't forget to show your work. Now, if you do traditional f of x, f of 2, you just plug in 2 into this thing, and you get your answer. But I went out of my way I wanted to get you to do it a particular way. Use the remainder theorem. The remainder theorem says when I use synthetic division on dividing 2 into my synthetic, the coefficients of my polynomial, the remainder that I get is equal to f of that number, the functional value. That's called the remainder theorem. So the remainder is equal to f of whatever value I'm plugging in. So what I really wanted you to do was, and I left you just enough room to do it, synthetic division. So my C number is going to be 2. We're going to do synthetic division into the coefficients of my polynomial, which is 2, negative 11, 7, and be careful on the synthetic division. If there's a term missing, you got to put 0 in for it. So that's a cube, squared, x, and constant. So there's no term missing, but remember, signs go with it. So it's 2, negative 11, 7, and negative 6. Skip a line, draw a line. Bring down your first victim, 2, and below the line you multiply. 2 times 2 is 4. Above the line you add. Negative 11 plus 4 is negative 7. Multiply. 2 times negative 7 is negative 14. Add. 7 minus 14 is negative 7. Below the line multiply. 2 times negative 7 is negative 14. And then add, what is negative 6 minus 14? Negative 20. And according to the, quote, remainder theorem, the remainder that you get from the synthetic division is actually equal to the functional value of the point you plugged in. So therefore, f of 2 has got to be equal to negative 20. But this is my work. I didn't want to plug in 2 and cube it and multiply it times 2. I get the same number if I did that, but this is the work on the remainder theorem. Yeah. Right below it? Oh. Okay. Divide using a long division. Okay. So, without doing long division, I left you enough space to be able to get this in there. So let's see here. Long division. Divide. The dividend, the guy we're dividing into, is this guy. X to the 4th plus 3x squared minus 5x plus 3. You'll notice that there's a term missing on this guy. Who's missing? X to the 3rd. These polynomials have to be in decreasing order. So when there's a term missing, make sure you put 0 in for it. X to the fourth plus 0x cubed plus 3x squared minus 5x plus 3 divided by, this is your divisor, x squared plus 3x minus 2. Okay? Now, I'm not going to do all this problem, but I'm going to do most of it, get you started on this thing. It's a game of what do I need to multiply x squared by to get x to the fourth? X squared. So I'm going to put an x squared up here. You with me? And then I'm going to multiply, and that means I'm going to distribute through each one of these terms. So x squared times x squared is x to the fourth. X squared times 3x is plus 3x cubed. X squared times a minus 2 is a minus 2x squared. So I took that x squared and I multiplied by each part of my divisor on each term, and I put it down here. But I'm doing long division. After I multiply through, what do I have to do next? Subtract, which means I want to change my signs. So I'm going to subtract these guys, and so subtraction changes my sign, so that'll be a minus 4x cubed. That negative distributes, so change your signs. That becomes a minus, and this one becomes a plus. So, and the first term should always cancel, because if it doesn't, you screwed it up. So x to the fourth minus x to the fourth is 0. Now I got 0x cubed minus 3x cubed is a negative 3x cubed. And I got 3x squared plus a 2x squared makes a plus 5x squared. And then I bring down the next victim, minus 5x, and I play the game all over again. Let's do it one more time. What do I need to multiply by x squared to get a negative 3x cubed out of this guy? Negative 3x. What's your signs? Negative 3x. Negative 3x times x squared is a negative 3x cubed. Negative 3x times a positive 3x is a minus 9x squared. A negative 3x times a negative 2 is a plus 6x. But now, what am I going to do? Catch the pattern. I'm going to subtract, which changes my sign, so this thing becomes a plus, this thing becomes a plus, and this term becomes a minus, because that negative would distribute and change all my signs. And you'll notice that the first term cancels. What are you left with? What is 5x squared plus 9x squared? 14x squared. I got a minus 5x minus a 6x, that is a minus 11x. And now I'm going to bring down my next victim, plus 3, and I'm going to let you guys finish up this game. But now, the other part of this thing, so you guys have to finish this one up, but the other part of this game is this. Okay? How do I write my answer? Quote, I want you to use the division algorithm format. So let me remind you what the division algorithm format is. When I'm doing long division, this is the dividend. It's the guy underneath the radical, what you're dividing. You have this is the divisor. Up here is the answer. The fancy word for answer is the word quotient. And down here, you're going to get something that after the divisor degree is bigger than what's left over. This is called the remainder. The division algorithm says you want to write the answer in this format. So this is the division algorithm. The dividend is equal to the divisor times the quotient plus, run out of room there, the remainder. So, if you keep doing this problem down here, you're going to get a remainder right down here. So the answer, the way I want you to write it, would be, take this polynomial right here, the dividend, that will be equal to the divisor times the quotient, and remember there's an extra term you've got to figure out right here. It's around 14 or something. All right, then multiply this times this, and then add it to the remainder. So this is the format of what the answer should look like. Does that make sense? The dividend equals the divisor times the quotient plus the remainder. So the answer is going to look like this when you're done. x to the fourth plus 3x squared minus 5x plus 3. That is your numerator, or your what we call the dividend, would be equal to the divisor. The divisor is the x squared plus 3x minus 2 times, here you're going to put the quotient. That answer, when you finish it up here, goes here, plus, and then you got to put right here, you put the remainder, whatever you get down here when you're finished dividing. That's the division algorithm then. Yeah.
Well, it's not on your notes, then ask for another question.
Okay. Does that make sense? But in part number 5, what did I ask you to do on this one? I asked you to do synthetic division, but you'll notice you can only do synthetic division when you divide by, quote, x minus c. So when you divide by x minus c, I've got x plus 2. What does that make your c value to be? -2. You would put -2 into the coefficients of this particular polynomial. But notice something or other very, very important. There's a term missing. There's no x cubed. You got to put a 0 in for x cubed. Yeah.
How did you know that the divisors couldn't go into the last one?
How do I know the divisor can't go into the last one? Well, because look at your degree. This is 14x squared. What do I need to multiply x squared by to get 14x squared? Okay, 14. So you put the 14 up there, and then you would distribute them through. And then you're going to subtract. And you're going to get x term left over. How does x squared go into an x? It doesn't. That guy becomes your remainder. When your degree of the remainder is less than the degree of the divisor, you're done. That's how you know it's the remainder, because you can't divide something small, bigger into something smaller. Does that make sense? Okay. Yes, ma'am.
Are you asking for questions on that question, or are you answering?
Either one.
Okay. I had a question about number 9, D. On the
9D. But before I do 9D, and before you have a cow, what was your question, darling? It's all right.
I don't know if it's on this because I don't have the paper, but, could you do a problem that has like when you expand or condense the log? Do you know?
Oh, it's all over this thing. Sure, I'll do one of those. I'll make up one. But 9D, that one. Okay. All right. Look at 9C versus 9D. There are two different log equations up here. This one is a log, what I call a log type 1. This is logs on one side equal to a number. When you have logs equal to a number, you combine logs, but you use the smiley face definition to write it in the exponential form so you can solve for it. This is a log type 2. This is logs on both sides. I just chose natural logs, but it wouldn't have mattered. How do I solve a log type 2? You guys asked me to do D? All right. Notice what is the coefficient in front of my logs on both these guys? These are natural logs, log base e's. What is the coefficient in front of the logs? Understood to be 1, because you don't see a number there. Implied 1. What does subtraction turn into so I can combine logs? Division. One big log, this would be one big natural log of division. The positive term goes on the top, 5x minus 3. The subtraction term goes in the denominator, 2x plus 6. But remember, it's just one log. Don't just divide natural log divided by natural log. That's not in the log properties. You're combining logs, you get one log, and you just divide the terms that we're taking the log off. Equals the natural log of 5. As we were mentioning before, when I have log of somebody, regardless of the type of log of somebody equals the log of somebody, what do I get to do with the logs on a type 2 equation? Cancel. Officially, I would raise e to both sides because that's the mathematical process that you do to eliminate the log. But basically, I can just cancel the log on one side, it cancels the log on the other. That's a legal math move. This is going to give me 5x minus 3 over 2x plus 6 equals 5. Now, how are you going to solve for x on this thing? What would you do? Multiply both sides by your denominator. 2x plus 6, multiply by 2x plus 6. On the left side, it cancels. You're left with 5x minus 3 equals 5 times, lost my 5 there, 5 times 2x plus 6. What you going to do now? Distribute. So I get 5x minus 3 equals distributing. This is 10x plus 5 times 6 is 30. So now I'm going to solve for x. I'm going to subtract 10 from both sides, minus 10x from both sides. 5x minus 10x is a negative 5x. Minus 3 is equal to, this cancels, 30. I'm going to add 3 to both sides. So I get negative 5x equals 33. And then what's the last move to solve for x? Divide by negative 5. When I divide by negative 5, I'm going to get the answer negative 33/5. Does that make sense? Did I lose you anywhere? All right. Here's my question. Are you done with this problem? On log equations, you're never done. You've got to check your answer. And I'm not checking to make sure this is right. I came up with a crappy fraction. I'm checking to make sure that when I plug it back into the original equation, I'm not violating a rule of math. I can't take the log of a negative number. So what exactly is negative 33/5? Negative 33/5 is pretty much negative 6.6. Does that make sense? So when I plug in negative 6.6 on this thing, go back and double check it. What is 5 times negative 6.6 minus 3? Negative 36. Can you take the log of a negative number? No, that violates rules of math. That's why always check your answer. So I am checking this guy. But when I check by plugging that number into this guy, and I can plug it into both of them, obviously, but if just one of them violates a rule, when I plug in negative 33/5 into 5x minus 3, I get negative 36. I can't take the log of a negative number. By checking it, this thing does not work. Does that make sense? So what's your answer? No solution. And I would accept does not exist or no solution. I'm happy either way you want to put that. There you go. Yeah.
On the last one with the division algorithm,
Yeah.
it's the dividend equals divisor times
Quotient plus remainder. Yes. Yes. That's the division algorithm. So there's a big old, you'll see it right here. Let me flip it back over. It is dividend equals divisor times quotient plus the remainder. Right. Okay. Yes, ma'am.
Can we use 9B?
9B. All right. 9A and 9B are very similar. But I got 9B. The natural log of negative 5x plus 6 equals 3. Mission, solve for x. How would you solve for x on this thing? Well, this is a log equation, but type 1. Type 1 meaning you've got logs on one side equal to a number. All right, and there's nothing combined. I only got one log on this thing. But here's the question. What's the base on this log? I got a natural log. What's that understood base, even though I didn't write it down there? E. That number 2.81828, whatever. 2.71828, whatever. E. Now, if you have a log equation and you want to get rid of the log so you can actually understand what the equation is, you use the definition of logarithms. Rewrite it in the exponential form. The smiley face definition for all intents and purposes. So, I'm going to take E, I'm going to raise it to the other side, and it'll be equal to what I'm taking the log of. So this is rewriting the logarithmic equation in exponential form. This would be E cubed is equal to negative 5x plus 6. E cubed is just some crappy number. Solve for x. If I was going to solve for x, I would subtract 6 from both sides. That gives me E cubed minus 6 equals negative 5x. Then I divide by negative 5. That gives me x is equal to E cubed minus 6 over negative 5. E cubed minus 6 divided by negative 5. And there's my answer. But some people, that just freaks them out. That's all right. We're happy to take it either that form or the decimal form. But if I do decimal form, I got to put parentheses around my numerator. That'll be E cubed E is located right above the natural log button. It's in blue on this thing. E cubed minus 6, close parentheses, divided by negative 5. I would also accept negative 2.817107385, whatever. But now, are we done with this problem? It is a logarithmic equation, so I need to check it. So the answer is about negative 2.8 whatever. What's negative 5 times negative 2.8? Positive something. Plus 6. More positive something, brother. So when I plug this answer into this thing, it actually does work. I am taking a log of a positive number. So this is my solution. Does that make sense? Let me get back to the log property one. Now, which way do you want to go with this one? You want to take the baseball bat and beat him to death? Or you want to put him back together again? You want to put him back together again. All right. Now, with that kind of concerning thing, I'll do both. All right, let's take the baseball bat. So here's one. Log base 3 of 3x cubed y to the 6 divided by w to the 8 times the square root of t. If I'm going to do one, I'm going to do one like I would put on the test. Directions on this guy would be this. Rewrite in terms of multiple logs of single variables. That's the proper way of writing the directions on this. However, the reality is take your baseball bat and bust this thing up. Here's the deal. I don't do square roots. What's a square root? I want radicals in terms of fractional or exponents. So radicals are fractional exponents. What is a square root also known as? 1/2 power. Things you guys need to know. A cube root is a 1/3 power. A square root is a 1/2 power. So this is the same thing as this. The log base 3 of 3x cubed y to the 6 over w to the 8 times t to the 1/2. Now, multiplication turns into addition. Division turns into subtraction. Multiplication is in the numerator. If you're in the denominator, you're dividing, because that's the purpose of being in the denominator. You're dividing by the guy. So this would be equal to, when I clean it up, everything in the numerator is being multiplied. Multiplication turns into addition. This would be the log base 3 of 3 plus the log base 3 of x cubed plus the log base 3 of y to the 6th. But the w to the 8th is in the denominator. Denominator means divide. Division turns into subtraction. That'll be minus the log base 3 of w to the 8th. But where is the t to the 1/2 located at? Where's the t to the 1/2 located at? It's in the denominator. Denominator means divide. Division turns into subtraction. Minus the log base 3 of t to the 1/2. Now, I know some people are going to argue with me. I see multiplication right there. Doesn't multiplication turn into addition? Yes, but you're looking locally. This is in the denominator. You need to look globally. Globally, these two terms are in the denominator. Denominator means divide. Division turns into subtraction. Does that make sense? But I'm not done yet. To rewrite it in terms of logs of single variables, where do my powers get to go? Where do my log properties say about powers? They go in front of the logs. So this would be plus 3 log base 3 of x, plus this power pops out front, 6 log base 3 of y, minus this 8 pops out front, 8 log base 3 of w, minus 1/2 log base 3 of t. One last little log property here was this log base 3 of 3. What is the log base 3 of 3? Very good. That's a log property. That's one. Again, knowing your log properties, the log base a of a is equal to 1, and the log base a of a to the x, exponentials and logs cancel, you're just left with x. So log base 3 of 3 would actually be 1, and this would be that multiple choice answer that we're going for. Does that make sense? But now let me go in reverse, because you know I'm going to give you one of each different type on your test. This one was rewrite this big log in terms of multiple logs of single variables. That's the Humpty Dumpty problem. Here's Humpty Dumpty. Take your baseball bat and bust him up into a bunch of pieces. Now, part 2. Here's Humpty Dumpty and a bunch of pieces, putting back together again. Rewrite as a single log is what the directions would be. And I'll do natural logs on this one. Natural log, 2 natural log of x minus 3 natural log of y plus 4 natural log of z plus w squared minus 1/2 the natural log of t. There you go. I want you to rewrite this back as a big log, a single log of multiple variables here. To be able to combine logs, the coefficient in front of the logs have to be a 1. So if you got a number in front of the log, where did he come from? Where does he go back to? The powers, the exponents. So this would be equal to the natural log of x squared minus the natural log of y cubed plus the natural log of z plus w squared raised to the 4th power. Remember, you can't distribute logs. You got to leave this dude alone. Minus the natural log of t to the 1/2 power. Now, here's the simplification of this whole idea. Now let's put Humpty Dumpty back together again in terms of one big log. This would be equal to one big natural log of a big old fraction. Multiplication, addition turns back into multiplication, and multiplication shows up in the numerator. Subtraction turns into division, and division shows up in the denominator. So it's all about the sign that is in front. What is the sign that is understood to be in front of this natural log of x squared? Positive, plus, so the x squared goes on top. What is the sign that goes in front of the natural log of y cubed? It's a minus. So where's the y cubed going to go when you combine logs? In the bottom, the denominator, y cubed. This is a plus. So where is this term z plus w squared to the 4th going to show up at? Because it's a plus in the top. Z plus w squared to the 4th. And last but not least, where is where am I going to put this minus natural log of t to the 1/2? Where's the t to the 1/2 going to go? In the bottom, because it's a minus. Minus means divide, division bottom, and there's my answer. And by the way, I could have also done this, just if it was a multiple choice question. What's a 1/2 power also known as? I could have written them as a square root, and that would have been the same thing. And typically on multiple choice questions on exams, that's what they like to do. Does that make sense? Did I lose you anywhere? Okay. So somebody else had a question. Right there it is. Thank you. Yeah.
Could we do 10C?
Okay, we're on the free response part. 10C. All right. Let me give you guys a hint on each one of these guys. For example, 10A. These are exponential equations. There's only one thing in the universe that brings down exponents, and that's logs. But there's a rare occasion that you don't need to use a log, and that's when you can write the equations in the same base. In this first one, I'll just get you started on this one. I got 4 raised to the 2x plus 3 equals 16 raised to the negative x plus 15. Okay? But I can actually write 16 in terms of base 4s. What's 16 equal to? 4 squared. So this is 4 raised to the 2x plus 3 is actually equal to 4 squared raised to the negative x plus 15. Now let's go back to your 4th grade exponential properties. Power raised to other powers, what do I get to do with the powers? Power raised to a power, what do you do with powers? No, we're not talking about logs. Power raised to a power, you multiply. All right? So this would turn into 4 raised to the 2x plus 3 is equal to 4 raised to the 2 times negative x plus 15. Because I can write this equation with the same base, when the bases are equal to each other, what does that imply? The exponents have to be equal to each other to be totally equal. So in other words, that 2x plus 3 has got to be equal to 2 times negative x plus 15. And now go and solve for x. Does that make sense? However, this one has got an e in the problem. It's an exponential function with an e in the problem. What kills off e's? Natural logs. But the only way you can kill off an e is you gotta take the natural log of e, because the natural log of e to the x is equal to x. You gotta get the e by himself. So what is my first move on this particular exponential equation? What's the first thing you gotta do to get the e by himself? Divide by 500. Get the e by himself so you can kill him off with the natural log. You gotta isolate your victim. Get the e by himself. Does that make sense? Now this last one, it's another exponential equation. I've got 8 times 3 raised to the 2x plus 4. Order of operations, what comes first? Inside parentheses. What comes next? Exponents. What comes next? Multiplication, division from left to right. What comes last? Addition, subtraction from left to right. So, do not do this. 8 times 3 is 24. This will be 24 raised to the 2x plus 4. You violated 45 rules of math. Basically, you've just violated the order of operations. Exponent comes before multiplication. You can't touch these guys. So the first move you should make on 10C is get the exponential dude by himself. So my first move is to do what? Divide by 8. And this is something you guys should know without a calculator, but we'll decide on that one later. What is 56 divided by 8? Some of you people worry me. 7, that's right, it's 7. There you go. All right, now, here's the deal. I'm trying to calculate an answer. And since I'm going to calculate an answer, I'm going to use the logs on the calculator. I got a natural log and I got a common log. And it honestly doesn't matter which one you use, but here's my rule of thumb. If I've got an e in the problem, I'm going to use the natural log. If I don't have an e in the problem, I'm going to use the common log. Do I have an e in this problem anywhere? Nope. So what I'm going to do here is I'm going to take the log of both sides, because the only thing that brings down exponents is logs. But what I do to one side, I do the other. And this is log base 10 on my calculator. So this is the log of 3 raised to the 2x plus 4 equals the log of 7. But thanks to log properties, once I take the log of both sides, where does that exponent, where the variable is located at, where does it get to go to? To the front. So this turns into 2x plus 4 times the log of 3 equals the log of 7. Now you're trying to solve for x. Log of 3 and the log of 7 are nothing but crappy numbers on your calculator. They're just numbers. So if I wanted to solve for x, I want to get the x by himself. So the next move I would do would be divide by log 3. When I divide both sides by log of 3, this is going to give me 2x plus 4 is equal to the log of 7 divided by the log of 3, a number that will be on my calculator. But I want to show you this answer because on multiple choice questions that the folks that make up the final exam give you, sometimes they like to write it in log form. So we'll leave it in log form here. So this is log of 7 over the log of 3. I'm going to solve for x. So I'm going to subtract 4 from both sides. That gives me 2x is equal to the log of 7 divided by the log of 3 minus 4. And then I'm going to divide by 2. This is going to give me x is equal to the log of 7 divided by the log of 3 minus 4 divided by 2. There's my answer. Now I will put this on the calculator here just to let you know what it really is in terms of decimals and stuff. But I want to show you one other thing. Because of the change of base formula we taught you guys about using your calculator in terms of change of base, what exactly is the log of 7 divided by the log of 3 also known as? That's also known as the log of base 3 of 7. This and this are the same thing called the change of base formula, minus 4 divided by 2. That's another way I could have written the answer. I want you guys to be familiar with both ways. But what the real answer, so I would accept the answer as x is equal to the log of 7 over the log of 3 minus 4 all over 2. Or for you decimal fans out there, here we go. I get parentheses around the numerator, log 7 divided by log 3 minus 4, close parentheses for the numerator, divided by 2. The answer is also negative 1.114378125. Yeah.
So you could write it as log base 3 of 7, that's what it is.
Yeah, I would also accept that as well, because it's the same thing, just a different way of writing it in the change of base formula. but that's why I also go decimals, just in case, I don't know if they may throw decimals at you, they may write it like this, or they may write it like this. You gotta be familiar with what they all look like and stuff. Has this been helpful? Now, the other thing I want to do in the last 3 minutes I got left in class here, and I've done a lot more of these things than I anticipated, but don't worry, I put a lot of questions on this thing. The fact is, and again, the whole purpose is to get you guys prepared to do well in tests. I wanted to show you guys what an old final exam looks like. And I picked one that, so you have this kind of template and stuff. This was, I just grabbed one from the internet. This was from 2011, but the format, we haven't changed. They actually are going to give you some formulas on this thing. These are the traditional formulas that they give you. So, you know, be familiar with these guys, but if you get in trouble and can't remember them, you can look these guys up. But if it's not on this set, they're not going to give them to you. The difference in sum of cube factoring, the quadratic formula they give you, find the equation of a line, point, slope formula, midpoint formula, distance formula, the equation of a circle, but how to complete the square they don't talk about. But notice down here in terms of our stuff, the compound interest, A equals P times 1 plus R over N raised to the NT, and A equals PERC. They don't tell you how to use it. They just tell you, okay, if you can't remember it, here's the formula for it. And then here's your log properties. Addition turns back into multiplication. Powers get to go out front, and division turns into subtraction. But the final exam, listen up, the final exam is going to be of this format. This is the common final exam. It's going to be 100% multiple choice for the entire exam. In the fall of 2011, and again, look at these exams and stuff, and look at more than one exam. If you look at these things, you can see that they're all different kinds of questions we've done in class. However, on this particular semester, they happen to have 40 questions. On average, they're 40. Sometimes they're 35, sometimes they've been up to 45. You guys, 37. Okay, so this is the number of questions, and you'll have 3 hours to do it. We'll look at this again on Wednesday, but remember, homework's due on Friday, and test is on Monday. Study hard, and I'll see you guys next time.